I've got an interesting page on here. It has our profiles for wind shear simulation.
Simulators help airline pilots train for hazards most hope they never have to face.
We've selected a wind shear that's going to occur at 200 feet after takeoff here. Now what's going to happen is we're going to get a warning, wind shear warning, okay? And our speed's going to drop off. You can see it's starting to get rough.
Wind shear.
But all the wind shear simulations he'd weathered couldn't help U.S. Air Captain Mike Greenlee outside Charlotte last July.
I've never had a sensation like that of just like having the rug pulled out from under you. I pulled the nose back up, and then we hit real hard, real hard.
27 people died in that DC-9. Like most U.S. commercial jets, it had been outfitted with reactive wind shear radar.
They had about 1,000 wires. 1,000 wires for wind shear.
The alarm is supposed to go off when pilots are in the middle of a potentially dangerous microburst of air. But Greenlee was in the process of reconfiguring the plane's flaps to go around and try for another landing. So the wind shear alert never sounded. Now, because of that accident, the Federal Aviation Administration is considering requiring all airlines to install newer technology that detects wind shear ahead of time.
Scientists here at Hampton's NASA Langley Research Center helped design and test that advanced warning radar system. Now some of those same researchers are focusing their attention on another airline phenomenon that may have contributed to another U.S. air accident, wake vortex.
Investigators say the 737 that crashed last September outside Pittsburgh may have encountered another plane's wake, then had a rudder problem. As shown in this NASA video, all planes create a wake vortex. But without man-made smoke or specific weather conditions, pilots rarely see the turbulent air.
As a byproduct of an airplane developing lift, you'll have the air rotating around the wingtips from the higher pressure to the lower pressure areas, and it generates basically what could be considered a horizontal tornado.
Dave Hinton is part of a team of Hampton scientists studying wake vortex with the help of a mobile laboratory from MIT. Both have been at the Memphis airport, along with a specially outfitted plane, to observe and record flight and weather data.
Okay, he's going to be a 757 or an Airbus.
Bigger planes leave bigger wakes, so air traffic controllers have to keep different types of aircraft some distance apart, especially on takeoffs and landings. But pilots know weather, altitude, even time of day also play a part in dissipating wakes. NASA's goal is to add up all those factors and come up with a system to increase capacity at major airports without compromising safety. Kathy Barnsdorf, 13 News.